Hey everybody, how's it going? This is Seth Williams. You're listening to the REtipster podcast, and today we're digging into a topic that every land investor really needs to understand, but few really do. And we're talking about septic and sewer systems. If you've ever looked at a property that doesn't have access to city sewer, you've probably wondered to yourself, hey, can I put a septic system here? And what if it doesn't pass a perc test? And how much is that going to cost me? And to help us get a clear idea on all of that, I'm talking with Mitch Klein. He's a civil engineer who specializes in sewer design, wastewater, and drinking water systems. And Mitch has worked on everything from private septic layouts to large-scale public sewer systems, and he knows what really determines whether a piece of land can handle development. And we're going to walk through how to assess a property and what the key deal breakers are, and what options exist if it fails a perc test, and what land investors need to know before buying land that doesn't already have utilities in place. It's going to be a fascinating conversation. I've wanted for years to talk to somebody who really has a deep understanding of this to help us all understand it. That's what we're going to do right now. So let's jump in. Mitch, welcome to the show. How you doing?
Doing good. Thanks, Seth. And I appreciate the kind intro there. I'm really excited to be here. I feel like you're kind of like the gold standard for land investing podcasting. And so I'm really honored to be on the show, and hopefully I can bring some value to you and all of our listeners.
Oh, yeah, I appreciate that. And I'm sure you will. And just background for the listeners. So Mitch and I were talking for over an hour a couple weeks ago about this topic to prepare for this conversation. And man, just that conversation leading up to this one was a fascinating one for me. I didn't know how much there was to know about it, and Mitch just knew it all. So this is going to be great. So Mitch, let's talk about your background a little bit. You are not just a civil engineer, but you're also a land investor. So you have a foot in both of these worlds. But tell me about your civil engineering background and why are you qualified to speak on this subject?
Good question. So I started off in the civil engineering profession, started with a bachelor's, then got a master's in environmental civil engineering, emphasis on water, wastewater at the great University of Nebraska, which I know a lot of people are really impressed by. So you can soak that in. But started with that, was able to work for a couple of top 10 national engineering firms, really big firms with tons of experience, expertise, taken on both small and large sewer, wastewater projects. And then had a chance also to work for a more local firm here in the Nebraska area, which really gave a good intro to kind of septic and more specific private applications on the sewer side. So I've been really blessed and lucky to kind of touch on a lot of different types of projects when it comes to water and wastewater. So jumped in, and about 3 years ago, a buddy and I started investing in land as well. And he had been doing probably about 40 properties before that. And we were talking about passive income and different ways to kind of supplement income. And I was like, there's no way that works. Like, there's just no way that works. He's like, well, it does. I've done over 40 properties, started talking through the numbers. And I was like, I got to get in on this somehow. So we partnered up for a few years. Our business philosophy's kind of shifted a little bit. So I bought him out and I've stayed in the game this past year. We've got one VA employee, Jamie. She's awesome. Yeah. So we've kind of got a little bit of foot in both worlds and have started my own engineering consulting firm as well this year to supplement, especially, there's the septic discussion, there's potential for sewer discussion when you get into subdivides and even into potential entitlements. That conversation really becomes pertinent, really becomes important. And it depends specifically on different areas, but sewer really can make or break the potential for bringing in single family homes versus just having to be stuck with just an acreage on the subdivided spot. So I've really started to dabble in both that with our business, but also helping out other developers with the engineering job to kind of get through some of these problems and come up with solutions.
And we actually had talked about this subject a little bit in episode 228 when I interviewed David and Emmanuel and Arturo about a big entitlement project they did. And in that project, the sewer system played a very important role in making that thing work. So just to back up what Mitch is saying, like the ability for an entire subdivision to have access to a sewer or not is a huge deal. I mean, it just changes everything about the sizes of the lots and whether their things are even buildable, all that stuff. And one other thing just to mention is that Mitch's other expertise is in water, like well water and city water and that kind of thing. And we actually decided to try to split this up into two separate conversations. So the water access issue, it is related. Like there's a little bit of overlap when it comes to the septic because the water access in the septic can't be too close together. They do kind of play off each other, but it kind of is a different conversation. So we're going to try to split that one up into a separate episode. In this one, we're just focusing on the sewer septic issue because it's a huge one that can have massive implications for the value and usability of a parcel of land. When a land investor is looking at a parcel of land, especially if the plan is to build a dwelling there at some point, if that's the highest and best use is to build something on there, then in order to have a toilet or anything that drains down the drain and have that water go to the appropriate place, you either need to have access to a sewer system, if it's anywhere near the city and the sewer grid, or that's not available, then the next question is, can we put a septic system here? And one thing I had learned from you in our last conversation was that in most cases, the minimum size for a parcel to be able to put a septic system on there, would you say it's about an acre? In some cases, maybe a half acre, but for most intents and purposes, is 1 acre pretty much the minimum?
Yeah, and I've got to caveat it with the local jurisdiction defines what that size is, either the state, the county, or if you're within city, sometimes it'll allow septic based on just lot size. But yes, nationally, about an acre, if you're just looking for a quick review on what's the availability of child lots when you're looking at a lot, it's about an acre as far as space goes. It used to be a half acre, and there's instances where stuff's grandfathered in from older legislation, et cetera. But yeah, an acre's a safe number to go with as far as how small your lot could get if you're using the septic approach. And I do want to add, within engineering, you want to keep your wastewater and your drinking water separate as much as possible. And that's really drives a lot of the design for both, is making sure that there's that safety built in to these systems.
Now, when you say keeping them separate, we basically just mean anything that goes down the toilet or down the drain and eventually makes it to the septic system. We don't want any risk of that contaminating where the drinking water is coming from. So as a general rule of thumb, how far apart do they need to be? Is it a minimum of X number of feet, or how should that work?
It really depends. It really depends on the jurisdiction. I've seen places where it's 200-300 feet. Sometimes it's down to 100. It also has to do with your soil. It gets complicated depending on your soil types as well. And water can travel through media, right? Through different soil types or sands, et cetera. And so ultimately, yeah, you want to make sure that if you have a well in the area, and even certain distances from the environment, so a creek or an open body of water, you want to make sure that that septic system is far enough away that the appropriate amount of treatment of that water occurs. And so space is the easiest way to comfortably and confidently accommodate that.
And when we say treatment, we just mean the soil treating the wastewater, right?
Yeah. And if you want to jump into what is a septic system, there's a tank, right? You think of the septic tank. So you've got water that leaves the home in just a pipe that's at an angle. So gravity feeds to your septic tank. The standard conventional septic system has one chamber that will allow water to settle out its particulates or any sort of sediments. So solids go to the bottom slowly. So if you slow flow down, you can allow for settling out to occur. And then also there's a scum component. So you have sludges at the bottom, scums at the top. Scum is like your fats, oils, and greases, stuff that's less dense than water. That will rise to the top. Then you have a set of baffles that will allow water to go through it kind of at the middle, if you think of that. So the top is prevented from flowing to the next chamber, and the bottom is prevented from flowing to the next chamber. The middle then flows into another chamber, and then that chamber either disperses for a standard septic system, will go through a series of pipes to a leach field, which is essentially long stretches of perforated pipe that are buried as well. So this whole system's buried. It's all underground. And then that water flows out and interacts with the soil. Most of your treatment actually occurs in the leach field as that water interfaces with the soil. So soils, depending on the area, are actually alive biomes full of different unique bacteria and different organisms that actually will feed off of the nutrients in our waste, right? So it's kind of a cool thing. But then there's a filtration component that occurs as that water slowly permeates or percolates through the soil or sand or whatever. And so that's how you get the treatment, is through those kind of multi-step phases of your standard septic system.
When we're talking about treatment, I assume the soil type matters, right? There's probably certain types of soil that treat wastewater better than others, right? So like, how do you know that the correct type of soil is there, and what is the correct type of soil?
Yeah, and you can achieve it with sand, but it's more of a filtration effort. The water has to travel through more to be able to get more purified. And it's not going to be pure water by any stretch, but it is a lot cleaner as it goes back into the environment or settles down into the groundwater pool. But to answer your question, it really depends. And ultimately, the local jurisdictions will define what the criteria are for that soil type. And a lot of people listening have heard of the perc test, right? The dreaded perc test, if it's questionable and if it doesn't pass, usually, in my experience, a lot of people will walk from that opportunity. But if it does pass, they can go with the conventional septic system, which is usually cheaper, more affordable, and standard for installs. That test really tells you how much water can go into and how long it takes for it to get into the soils and slowly leave the leach fields and leave the septic system.
Given that it's possible for water to perk too quickly, it's not just a matter of it draining fast enough, but it could go too fast if it's like all sand. Does that mean if it does perk too fast, you still might not be able to do a septic system because it doesn't go slow enough?
Potentially, or you'd have to modify your system, which usually, if you're looking at it from a business case, that means you're spending more money to do different modifications or to somewhat isolate or slow down that percolation. So sometimes you amend the soils around the leach field as one option. Another is there's like sand mounding, which is like an additional type of septic system where you actually build a bunch of sand and a bunch of different types of soils around that leach field so that you're more confident with what's happening after that water leaves the system. It ultimately comes down to your local jurisdiction and what those requirements are. But yeah, it is based on soil type and soil permeability.
Now, you mentioned something earlier about not only the soil type and the rate of percolation, but also like the minimum size of the parcel when you officially can do a septic system or not. How this all comes down to the local regulations and what they allow. So it's something a very important step to look at this, which I don't know that many people really do, to be honest. But what exactly are we looking for? Like if I've got a parcel that I'm looking to buy, say it's 0.9 acres, like a little under that 1 acre threshold, what am I Googling to find these local regulations? What is the document called? Once I find the document, what am I looking for in it? Like how do I really get clear answers to these questions to know if I'm likely to be okay or not?
So there's a couple ways you can go at it. The first, I would just Google such and such state septic requirements. And then is your parcel within a certain county? See if that county has any septic requirements. And then maybe get on the phone and call one of them or septic installers in that area. And usually if they're worth their salt and they've installed a handful of septic tanks, they know this like the back of their hand because these are the regulations that tell them if they did a good job and they can leave the site and move on, or they have to redo a certain component of it. So yeah, at a high level, I'd double check your state and your county, potentially city if you're within city jurisdictions, and then maybe get on the phone with the septic supplier and just see if they can talk you through it as well. And they're usually more than happy because you're a potential client as well to work with you.
It sounds similar to most regulation issues where, I guess, first of all, you got the national standard, but what really matters is like, okay, now we're at the state. Now we drill down to the county and possibly down to the city if it's in a city to see, do they have a sewer system? And if not, what does that city require? In terms of like the actual document I'm looking for, is it like such and such regulations? Or to your point, do I not even bother with that? Like just find a septic installer and ask them. Like they're the ones that can dumb it down for me and just tell me what really matters.
That might be the quickest. If you want one call, find somebody in that area, confirm, and then just pelt them with your questions. And usually they're happy to work with you. It's been my experience.
In terms of like the soil type, I know there are USDA maps, things like that you can find in Land Portal and other data services. How accurate is that? Is that even worth my trouble to do that? Okay, I find the property, find the soil type, put it in ChatGPT, figure out what this means. Are those maps even accurate? Or is it better to just call the septic installer and ask them the question and tell them to look at the property and tell me the answers?
Great question. I think it's still definitely worth a look. And the soil information there, and you've actually got a couple of podcasts on different soils and how to utilize that tool. Looking at that through the lens of septic, it's as good as the information that's put in there. So some areas, if they do a geotech boring or some other well boring, then oftentimes that information will get fed up to the USGS system. So if you're close to one of those borings, you're that much more confident with it. Now, the exact line of the end of soil type A versus soil type B, that's just an extrapolation from the information that they have. So you can't really depend on those boundaries. So if you're close to a boundary, question the data a little more, if that makes sense. But if you are just looking at like this acre of land is mostly this type of soil and that works for septic, that should work for your first go through. Now, as you're doing further research on the property, if you're talking to local real estate agents or if you're talking to septic installers, they'll be able to really help you drill down like, yeah. And actually going off of an example in South Carolina, got on the phone with my realtor and was like, hey, we've got a septic issue here. We have a potential perc test. He's like, oh, anything south of that ridge line, you're good. You don't even need to worry about it. The perc test is just a formality. Anything north, you're going to want to pay close attention because that may make or break if you can put the types of septic that you want to put in, or you're shelling out a lot more money to do an amended system or a pump system. I guess that's kind of a non-answer for you, but it's as good as the data going in, and maybe watch the boundaries is my advice.
On this whole note of the USDA soil maps, if you've ever looked at these, just a bunch of like squiggly lines going all over the place, making rough estimates as to the soil types in every single area. And I always wondered, like, how did they even get that data? Like, did somebody 100 years ago really go every square foot in the whole country and take borings of everything to know that? Or I know the answer to that is no, but it just makes me wonder, like, how much data is there really to go by? Like, you mentioned the geotechnical investigations, how when they do take borings, sometimes that gets fed up the ladder to the USDA and they might update that, like when they're putting in new highways and that kind of thing. But other than that, can it really be trusted? Or do you ultimately have to take soil samples to know?
Short answer, I think it's definitely trustworthy because there's good data in there. Now, it depends on what you want out of it, right? If you want it to tell you whether you can put a septic on or not, a lot of times when you're negotiating to sell or buy the property, the perc test is part of one of the contingencies of the property, right? And if you want to sell it to a potential homeowner or builder, they have to have sewer, right? So they're going to have a perc test on it. So in my experience, it's worth getting the perc test before you buy it so you know what you're up against on the back end. If you've got enough margin on the purchase and you could absorb even an engineered septic system for that lot or those child lots, I would recommend getting the perc test if that's what your end use is anyway. And oftentimes it's part of the negotiation, but as soon as that perc test is defined, then it's on that local jurisdiction to approve or give it thumbs up, thumbs down on if a conventional septic system can work in that jurisdiction.
So let's say I've got a property and it's the correct size according to the jurisdiction. The soil type looks good, passes the perc test, but it happens to be within a flood zone, whether that's the 100-year flood zone or the 500-year flood zone. Is that a problem? Like, do flood zones kind of disqualify a septic system?
Yeah, maybe a local jurisdiction might give an exception, but in general, this is a big deal. Flood zones, wetlands are federally enforced, federally defined, and then interpretation is local, but you're talking about a federal entity that ultimately defines what those are. And septic needs to stay away from both of those. So a lot of times that buffer zone or that distance away from your leach field from other things like a well, like wetlands, floodplain, like that all helps define where you can and can't put that's leach field as part of your system.
Sounds like flood zones are indeed a problem.
Yeah, short answer, yeah.
There is apparently, I've never done this myself, but I interviewed a guy a number of years ago. I still got the video. I'll put a link to it in the show notes. By the way, REtipster.com/246 to check out the show notes. But it is possible to remove your property from a flood zone in some cases. Sometimes these things are misclassified, or there's things you can even do to like build up a berm around your property, just to give you an idea. But if you are in a situation like that, say if the leach field is in the 500-year floodplain and you're like, really? Is it really? Can we take another look at that? There are services out there that can attempt to remove your property from a flood zone. Just keep that in your back pocket. But aside from flood zones being a problem, wetlands, I'm assuming those are a problem too, right? If you see wetlands on your property?
Yeah, wetlands are obviously good for the environment. They help filter It's one of nature's best filtration systems, is a wetland, and that's why they're protected so emphatically. But yeah, if you want to put a septic system in there, you should definitely be cognizant of wetlands.
I think sometimes, myself included, when I look at a property, I'm thinking through the lens of, okay, where is there enough room to put the footprint of a house? Is there enough room that's not wetlands for that? But I also got to consider what are the setbacks of the property, and also if there's wetlands or a flood zone, like there's got to be room for a septic tank and leach field in some cases too. So keep that in mind. And if there's not, you could be in trouble.
And you can get creative too, but the cost goes up with the creativity, if that makes sense. So
Hey, real quick, if you're a land investor, you probably know the chaos of juggling 5 different tools just to run your business. One for your CRM, one for your email, one for your websites, one for your calendar. And of course, none of these things talk that well to each other. And that's why I switched everything to Stride. It's the all-in-one platform built specifically for land investors. We're talking CRM, your website, your phone, texting, calendars, email, all the automations you could ever need, and even a ton of helpful AI tools now that can handle phone calls and text conversations without you even being there to do anything. And the best part is, it's all in one place. Since I made the switch to Stride, I've wiped out over $6,000 a year in unnecessary redundant software costs that I don't need anymore. And honestly, you could probably save even more. If you're ready to simplify your business, save money, get more deals, and get a whole lot more done, check out stridecrm.co and see what it can do for you. Again, that's stridecrm.co. Okay, now let's get back into the show.
There's an example property that actually Bob from the Wyoming trip, Bob and I were evaluating. And in order to make everything fit on the lot, there's this weird little bubble of wetlands that needed a certain amount of buffer. And it was almost smack dab in the middle of the property. And so your hands are tied. So there's the house footprint, driveway, house footprint, gravity drain to a tank. And then they had to pump it up across the front of the property to a leach field up towards the top of the hill to try to get everything to fit just right. But the wetlands is definitely part of that. But you're right. If septic is the route you're going for sewer or for wastewater, that you've got more stuff to shove onto that site.
So what about the slope of the property? Is that ever something that could mess up the viability of a septic system? Whether, let's say, if the backyard slopes down into a river or something, or if the whole thing is just steep in general, like, are there cases where you better watch out for the slope too?
Yeah, and it's more extreme slopes, so 10% usually is fine. But again, a lot of that's defined by local jurisdictions and what those septic design requirements are and install requirements are. But yeah, slope's another part of that. If you're looking for footprint, it should generally be not aggressively sloped, put it that way.
And that's another thing just to mention, like Mitch was just talking with Bob about the ability to pump sewage uphill in some cases if you really need to. So, I mean, ultimately, everything needs to flow downward towards gravity, but sometimes you need to get it to go up so that it can go down to the right place, right?
Yeah, and this is jumping over to more sewer design as well, but even just on specific homes for private entities, you can have a local or a smaller pump that is rated and built. They call them sewage grinder pumps to help if you've got grade issues or you can't use this area, et cetera. It can kind of help move your sewage to different parts of the property or tying into a sewer system that's over the next ridge or hill or whatnot. But as you can imagine, you put a pump in, you need electrical feed as well. Your equipment needs updating every so often. And so your overall price, both for install and for operation and maintenance, goes up as a result. Versus if you can do gravity, you put the pipe in and it lasts a lot longer. Everything just kind of flows downhill.
We have a pump in the basement of my house because there's a toilet in the basement. And in order to get it to go to the septic tank, it needs to be pumped up out of our basement and then into the pipes that then are gravity fed to the septic tank. When I was talking with my realtor when we bought this house, I was like, really? Like they do that? The realtor was like, yeah, probably like 10% of the houses I see have this thing in it. I was like, oh, wow, I guess there's ways to deal with that. And even in the house that I grew up in, we were at the bottom of a hill. And I always remember wondering, like, how does the sewer work if it's gravity fed? Like, it doesn't flow uphill somewhere. And as Mitch was explaining it to me, I don't know if there was a pump underground, but there might have been one that pumped it up out of there to get it to the wastewater treatment plant. So it's just really interesting stuff that I didn't know until I talked to Mitch.
As you get into evaluating if you're tying into sewer or not, with those jurisdictions, that's a big variable that some jurisdictions, cities or counties will put on the developer to handle whatever the new septic system is. Other jurisdictions will cover the cost or do a cost split. Like when you were talking to David Hansen or Brandon Cobb about sewer in particular, that's a lot of things that are going on. As the location, we're looking at it just from a developer specific lot or entity, but it has to fit into their overall sewer system. And that sewer system ideally is just gravity fed, which means you're following your standard creek watershed or river watershed, and you just kind of build it along, from the hills down into the valleys. And then your water treatment plant is at the lowest point. There's always exceptions, but typically the lowest point of that watershed to serve the town. But towns don't grow in the direction that watersheds are, and they jump over ridges and boundaries. And so sometimes you'll have to pump from one area over a ridge to the other. Or I'm working in a smaller town here in Nebraska that's so flat, they can't get the grade to get the pipes to go down. So within the development, I'm designing a pump station for the entire 82-acre development to pump it up, taking it from maybe 20 feet up to 10 feet across the highway to get into the city's existing system. So yeah, to your point, Seth, likely if you were at the bottom of the hill and there wasn't a treatment plant near you, it was getting pumped over to the next sewer system and then routed via gravity.
Mitch, there's actually a lot more I want to talk about with the sewer system and the pumps and all that. I think it's fascinating stuff. But before we go there, I wanted to round out the conversation on the septic systems. So the big question I think a lot of people have, I've heard many people ask me this over the years, and I never really had a solid answer for them, is, my property either won't pass the perc test or it does, but there's not enough room, or something is wrong and we need to come up with something other than your typical septic system. What are the other options? Say if the soil's not right, or there's too much of a slope, or there's not enough room, or whatever the issue might be. When you start getting into the new territory of, okay, we're going to start spending more money now to have an alternative septic system or an engineered septic system, what are the different types of alternative septic systems and how do they work?
Yeah, great question. So your standard septic or conventional septic system ideally is gravity and you've got the space. So just assume that that's all there. Goes into your tank with some baffles, and then it goes into a leach field, which is perforated pipe. And then that water then slowly permeates back into the soil.
I do think for some people, it would help to have visual aids of some of this stuff. You're doing a good job explaining it, Mitch, but even I had a hard time grasping it until I saw a couple good diagrams. So
I can send you a few.
Yeah. So whatever you have, Mitch, send them to me. As we go through this, I'll show it on the screen for those watching the video, or if people listen to just the audio, they can go to the show notes. Again, REtipster.com/246 to see some visual aids of what we're talking about.
Yeah, that does help a lot. I've obviously been working with them for decades now, so it's second nature. So you've got your standard conventional system, and there's the diagram to help kind of explain what's going on there. Then there's a few other ones. So one that's really common is called a mounded system or a sand mound. So there's nuance even within mounded versus sand mound, but in general, you go from your tank, and typically you could bury a bunch of sand to create that permeability that may or may not be there, or you mound, so that's where the mound comes from, and you just put it on top of the existing grade, and then your leach field is within that mound of sand and extra material. So that's the mounded system. Now, if it's up above, typically there's a pump that needs to then take the water from the tank up to your leach field. There's new technology that's coming out that's maybe less proven and newer. We'll just leave it at that. There's a micro mound system I saw online now. I've not designed anything like that, but it's almost like a drip style irrigation system. The problem with those is that those nozzles sometimes can get clogged, right? Because of what you're trying to convey through the system. There's an Elgin system, which I thought was really interesting. They're using geotextiles instead of sand or different soil materials. And then the line can get blurred. Then there's almost like personalized treatment systems, and some jurisdictions may require them. And those could include aeration, where you're actually introducing air and bubbles into your water flow, into your waste stream. And that can facilitate some of the bacteria that's already present in your wastewater to then kind of decompose or remove some of those different contaminants from the water before the water goes out. So there's aerations. You can be more intentional and have almost like a filtration type basin or system that isn't outside of the leach field, but you're forcing your wastewater through that system. And then there's different disinfection options as well. But this all gets to engineered treatment systems instead of just what we would consider septic. So it's kind of this spectrum as you go of more potential. You've got really bad soils or don't have a lot of space, but then your cost goes up quite a bit. And at some point, it becomes a regularly maintained and permitted treatment system instead of just a septic. And so circling back to septic, typical maintenance on a gravity septic system is every 3 to 5 years, that solids buildup in your tank needs to get evacuated or pumped out. So you'll get a vac truck that comes, they'll clean it out, and that's pretty straightforward. Every once in a while, you'll get issues where if you didn't do that, some of those solids will then go into the leach field and they'll plug your leach field perforations. So that's not good either. That price goes up quite a bit if you have to go through and clean out your leach field or build a new one if you've got space. Sometimes that's the case. Versus a pump, you throw a pump in there or some of these other treatment type systems, it's more mechanical based. You've got electrical components. And so the design life on those is a lot more reduced. And, your pump may be 10 to 20 years design life versus a tank. You put it in there and it's in there forever. You just clean it out every once in a while.
So when I think of these alternative septic systems, I might be wrong on this, but when I think of the most common alternatives, one would be, the correct soil isn't already there, so we're going to dig up what's there and replace it with the correct soil. And the other one being the mound system, it's where we're not digging anything up, we're just adding a mound of new soil to it and letting that treat the sewage before it gets into the soil that's already there. And I guess the bottom line in terms of why all this matters is cost, right? So a typical septic system, I think you said is 10 grand a normal range in most cases, or what would a normal one typically cost?
I've heard 6 to 18. A lot of that is your locale. Are you closer to a population center? Sometimes that's an advantage because there's more septic installers. Other times there's more demand if that area is booming. And so they can charge more. But yeah, 10 is a good budgetary number, but you call around and you can get some quotes pretty easily. And then you start adding all these other components to the system, your price goes up. So from some quick research beforehand, sand mound systems are 20 to 30K overall. And you start adding these aeration, filtration, maybe even UV disinfection, or you're dropping some chlorine in to try to treat it before it goes back into the natural environment. You're talking permitting, regular sampling. You got to get it designed by somebody who is a certified licensed engineer in that area. And then your cost, it can be up to 100, 150K, depending on the system. That is part of the business logic of the property and if you want to build a home on it.
Sounds like the engineered alternative system is about 2 to 3 times more than a normal one. And if you get all kinds of pumps and stuff involved, then it could be 5 to 10 times more than a typical septic system. Is that about right?
Yep. The complexity goes up. So does the cost.
This is just to be able to flush the toilet and have it go to the right place. We're not talking about all of construction. That has its own costs involved too. But just in terms of looking at a property when you know it has issues and trying to decide, is it worth it? Is the future buyer going to want to spend all this extra money? The answer is maybe, maybe not. Kind of depends on the market demand and, how hot of a commodity that specific property and location is, or if you can just buy the thing next door and not have problems. Now, when we're talking about these pumps, whenever I hear that kind of thing, my mind goes to, oh man, so now we've got the maintenance of the pumps, which you've already mentioned a couple times. How long do these pumps typically last? Are we talking you're going to have to replace it every 10, 15, 20, 30 years? And then what is the cost to do that?
Yeah, it really depends on how much crap you're flushing down the toilet, right? So if you're following the rules and it's just the 3 Ps, pee, poop, and paper, you're good. And obviously don't throw printing paper down there, but toilet paper and, other organics that can break down easily, your system is going to last a lot longer. There are some, and this is kind of a gripe within the water wastewater engineering space, there are some products out there that say that they're flushable, which is fine if it's a gravity system. But if there's a pump in that flow, it wads up and it will actually prevent the pump from working. It'll slowly build up and it'll get caught around that impeller. And so if it says flushable wipes, just throw it in the trash, like as much as possible, especially if you've got a pump in your system. That's kind of the high level of it. The actual design life typically is like 15 to 20 years if you're treating it correctly. And there's obviously instances, it's like a water heater. Sometimes they'll go for another 10 years and do just fine versus not. But yeah, that's roughly how often you should expect, or I would budget 10 to 15 years. And then it's good news if it goes longer than that, but you're ready if you've got one of these in your system.
I've wondered when these pumps stop working. I wonder this for my own situation because I've got a pump in our basement of our house. How do you know when they break? Like, does your toilet just stop flushing? Or if the pump is like deeper into your whole septic system and you don't even see it in your house, what is your clue that the thing is broken and you got to fix it?
Great question. So some of the newer pumps actually have alarms or lights that will beep if they're not working, like as an electrical circuit or the electricity goes out, etc. Some do, but if it goes out and it's not screaming at you, it will slowly back up in those pipes. So usually it'll show up in your floor drains first. So if your basement has floor drains as well, and it's on the same system, then those will start to back up first, and you'll know, you'll smell it, you'll see it. It's a problem, and you'll want to get it fixed right away.
I hope I move out of this house before that day comes. But my house was built in 1994. I don't think it's ever been broken or replaced as far as I know. So I feel like that day is coming for me pretty soon. So,
and you can always get somebody out to check it out, just like your furnace or just like other parts or components of your home. If you're like on the fence about it or you think it's not working right, there's usually professionals that could come out.
I prefer to let things become an emergency. That's usually my style. So I think I'm going to ignore that advice and just let it become a disaster. So,
well, at least budget for a new one.
Yeah, there you go.
So then it's not a shock. Yeah.
So let's pivot a little bit. We've already talked a little bit about sewer systems, but sewer is kind of like the preferred option, right? Because if you have a sewer, you don't even have to think about this septic stuff. So maybe the first step is if I'm looking at a piece of property and the first question is, hey, is there a sewer system? How do I find that answer really quick? Is there some website that says this nationwide, or where would you go to figure out, is there a sewer in front of this property or not?
Yeah, it's very localized to the point of the city or maybe the county, but usually it's the city that will have their own sewer system. So you call on their public works, depending on the size of the town. They may or may not know what's going on your first time you call. You may have to work through their local organization. You could get in touch if you are looking at a significant subdivision or even like entitlements. You could get in touch with the local engineering firm as well, or a planning firm. They may know the system because they've worked with that city on their system for quite some time. But yeah, in single source of truth, though, is the city itself calling, and they should pass you through to whoever it is that will know what it is. Some cities do have updated GIS systems, and you can just pull it up, and they allow the sewer to be part of what's publicly displayed. So I work a lot in the Omaha metro area. They have a sewer system layer to their publicly facing GIS system. And that is super helpful to know exactly what's where. Is it a pressurized system? Is there pumps downstream? Would you have to pump over a ridge? That kind of stuff. You can get that information really quickly if you're working with some of the larger municipalities because they make that publicly available. But if not, you got to pick the phone up. And I actually want to circle back a little bit. Sewer is preferred if you have higher density developments. If you're looking at acreages, septic can be cheaper after the install because all you have to do is pump it out if you're using it correctly. Versus a sewer tapping fee and then a continual cost, it may be less preferred. And if you've got your own septic system, you're not subject to rate increases or anything like that. So circling back to that.
Yeah, it's a good point. Thanks for pointing that out. And a sewer system, for the most part, is always paid for and maintained by the local municipality, right? So like, I don't need to budget for the sewer in front of my house being fixed. Or is there ever a case where there's maybe like a homeowners association where like, it is going to impact you? Like if you got to repair the sewer, everybody's HOA fees go up. How does that typically work?
If it's a handful of homes, the city usually has the capacity to just tie in right away. If it's involved, like you're looking to break out 20 lots, 30 lots, et cetera. And this is all defined. Working with the local sewer authority will help you with this kind of decision logic and what are the capabilities of their current system. But let's say, I'll just use the example. I'm working on a mid-sized development in Columbus, Nebraska, and that system is built out to handle the sewer of those lots. But we're talking quite a few lots, like a couple hundred lots that will go into this area, and some commercial, some multifamily, some single family residences. So it's kind of a multi-use development. That will need to coordinate with the city, and we'll actually have to pump it to connect to their system. And then we, from the engineering perspective, we will then have to confirm with the city that there's capacity and prove and affirm that to the state for permitting purposes, that there's capacity in their system to handle these additional flows. So that is where you can have some of those cursory discussions with the sewer authority. How that worked, though, is the development pays for all the sewer up to tying in. So it's dependent on the amount of flow you're adding to their system. Can their system handle the additional flows? And if not, then sometimes they put the cost on the developer. Sometimes they'll split the cost. Let's say it's from the edge of the property line to the treatment plant. They need to build another line. Sometimes that's split cost. Sometimes the city or county is happy to pay that because that means that's economic value and benefit to the area. So they're happy to cover that with taxpayer money up to that property line. It really kind of depends on more of the local and your specific property's goals and what you're trying to do. There's kind of a if this, then that kind of thing. So I guess to summarize that, talk to the local sewer authority and they can help you kind of walk through it. And they may need to get an engineer involved at some point.
If a sewer system isn't built to handle the new, what do you call it?
Loads. Yeah.
Is that because the pipes aren't wide enough or something? Like, is the answer, if they were to fix it, just replace the existing pipes with bigger ones? Or is that not really what we're talking about?
That could be it. It all comes to what was the city's capital improvements plan or master planning, their vision. And when they put these systems out, and they'll build kind of branch trunk systems out as the community grows. But yes, it could be the pipes aren't big enough. They don't have the right capacity. Or downstream, they have a pump station or a treatment plant that also isn't big enough to handle those additional flows. And so capacity improvements would be needed so that you can add those flows and not overwhelm the pumps or the pipes or the treatment plant downstream.
Yeah, I mean, this kind of thing, I could be wrong, but it sounds crazy expensive and time consuming to build and install new sewer systems. Am I accurate?
Yes. But again, everything's relative, right? Like if you're putting in a massive development, you can absorb those costs and that's just part of doing business. Versus if you're doing a subdivide with 5 child lots, in my experience, that's not going to pay for it. So there is kind of this certain threshold of size and quantity of additional flows that you're adding that could or couldn't justify this system. So I've got kind of an interesting use case in the KC area where there's 4 40-acre lots all together. It's an old farmstead. It actually has a sewer running through these ag fields. But because the north boundary of the property is a city and in a different county, that city owns that sewer line, but they cannot serve non-residents. So they can't serve the county per their requirements. So it's super random. I've not seen this. I've actually seen it a couple times through engineering, but not on the land development side, where you literally have a sewer that can handle all the flows through the property, but because it's not owned by that county, you can't connect to it. So we're looking at our best case is probably going to be setting up for septic instead, even though you could just gravity to the bottom of the hill, tie into the sewer, and everything would be fine for a higher density development.
A wastewater treatment plant ultimately has to be lower in elevation than any other dwelling that sends wastewater to it, correct?
That is the ideal because gravity systems are so much easier to maintain. But there are some wastewater treatment plants that actually sit higher for other reasons. Maybe it's footprint, maybe it's other constraints. And they'll actually pump from the lowest point up to the treatment plant. But that is the exception, not the norm.
Because where I live, in Michigan, there's water everywhere, rivers and lakes and all this stuff. So every wastewater treatment plant that I know of is next to a body of water. And I'm curious, what happens at a wastewater treatment plant? Like, what exactly are they doing to the wastewater? And what is the product that leaves that plant? Like, I'm assuming it's not crystal clear drinking water, right? Is it like just slightly less dirty water that they just send into the river and then that takes care of it? Or how does that work?
Great question. So what happens is you're talking like multiple years of college level courses to try to hit on all the different treatment opportunities and options out there. Just to preface the question.
These are the kind of questions I like to ask.
Maybe we sign up for a course together and we can learn all the nuance of it. But at a high level, there are multiple different forms of treatment. You want to get the solids out. Most of your treatment, if you can get your solids out, a lot of your contaminants will go out with it. So that's the sludge. Then the next easiest thing to remove is scum, right? Fats, oils, and greases that are less dense than water goes to the top. You get those out, you're already talking about a much cleaner flow stream than what you had before. But this is the thing with water, why there's so many of us civil engineers around, right? Because water and even wastewater loads are very unique, and water holds so many different contaminants and chemicals in it, right? It holds on to a lot of stuff and carries it with it, that it really is local to that waste stream, what your higher level exact treatment, I guess, is, and what those permitting requirements are. So there's primary, which is like the first round, is usually sedimentation, like we talked about, scum removal, sludge removal, scum removal. Then there's secondary level treatment, which sometimes you'll add air so that oxygen and bugs, meaning microorganisms, can then consume the rest of nitrogen, phosphorus, other contaminants. And then those bugs will then settle out. So you get a cleaner stream. And then there's tertiary, which would be like a disinfection of some sort, either UV or you're dropping some chlorine in there to get rid of any remaining trace chemicals or contaminants before it goes into the environment. So your second part of the question, I totally glossed over, right? Like years and years worth of information in 30 seconds there. But what is released into the environment needs to meet the local environmental standards. So they will typically make sure it is same quality or better quality than the receiving body of water, if that makes sense. So it's not going to be drinking water level most of the time. There are some systems that are complete 360 systems now. Gosh, I think Singapore might have a complete system where they will take it from waste all the way back to drinking water, but that's the exception, and that's super expensive and really more the exception than the norm, especially in the US. So fun fact, I live in Lincoln, Nebraska, and our treatment plant actually puts a little bit better quality water into the receiving body of water just because the soils there have a lot of salts and a lot of stuff that isn't good for the environment, but it's just the natural soil that the stream flows through. But the state standards are higher than that. So it actually improves the quality of the water as you dump it from the treatment plant.
And I guess that's part of the beauty of a septic system, because essentially with just the infrastructure that's there and the power of gravity, it's doing everything you just said. It's not like going through a giant factory assembly line to do all this. Like, it just happens because the sludge and scum goes to the bottom of the tank, and then the other stuff, leaches into the field. And it's kind of a beautiful thing, honestly. I mean, it's gross, but it's a genius invention, whoever came up with this, right?
It is really cool because ultimately there is treatment occurring, and that's just natural treatment. So as long as you're not putting plastics and other stuff into your waste stream, the actual treatment mechanisms are all natural treatment based. The septic system helps facilitate that and speed up that process of what nature would do naturally.
So in a wastewater treatment plant, all these sludge and scum that is somehow removed from the wastewater, I don't know if they're adding chemicals or if there's some giant filter it goes through or what, but where does that material go? Do they then dry it out and bring it to a landfill, or that's got to go somewhere, right?
Yep. And there's a whole layer of specialized design just for that waste stream then. So you're removing it from your overall wastewater flow system. There's different mechanisms. Sometimes there's belt presses, so they'll try to squeeze the remaining water out just to keep the solids. And depending on what is in that waste, you can sometimes land apply it in agricultural applications if it's clean enough. You can then take it to a composting facility and it'll break down further. Or if it is contaminated, there's instances where it'll go to landfill or incinerate, depending on what you're up against. So some industrial flows just have a lot of nasty in them and take a lot more treatment systems and processes to get them back to innate and not a danger to the natural environment.
I always had this idea in my mind that a wastewater treatment plant was basically just one giant Brita water filter. Is that accurate, or is that not really how it works?
No, you could do Brita. You could do that, but that's a lot more expensive and very inefficient compared to the systems. So like I said, there's primary, secondary, sometimes tertiary is needed, even more different treatment systems besides. So what Brita does is Brita kind of does some filtration, but it actually utilizes like a granular activated carbon. And I'll refrain from deep diving into that. But if you're interested, check it out. It's got an absorption mechanism that can pull impurities out of the water as well. And maybe we talk about that on our water discussion.
Sure. Sounds like a good topic for that one. So one last question on the treatment plant thing. What about a treatment plant where there is no body of water? Or does it just simply always have to be on a body of water? Like if it's in the middle of the desert or something, what do they do with the wastewater then?
Yes. So some treatments are actually lagoons. So it's shallow, very large. So you get a lot of evaporation occurring and then just the solids stay. So in a desert type environment, maybe a lagoon is part of your system that's set up to just use evaporation. And so evaporation is like one of the simplest ways to treat because the water then is just evaporated. It's gone. It's pure as it leaves. It leaves all the contaminants behind. That's one option that you could do. But if that lagoon should ever overflow, usually they'll have it near a creek or a lake or something like that.
Are you saying this lagoon is literally created as a result of the treatment plant being there, or the lagoon is already there? They just built the treatment plant near it.
Intentionally placed out there. So some of the smaller communities, most of their treatment, because they can afford to have an acre or two that's relative to the amount of flow that they have, they could just do lagoon type systems as well. Yeah, there's a lot.
Kind of a random question I meant to ask this sooner. How long do sewers last? Does it have to be replaced every 100 years or 200 years or longer or shorter? How does that work?
Yeah, so just at a high level, and there's always exceptions. My experience, you design your gravity sewer system, which is pipe and manholes. That is 100-year design life is what we shoot for. When you get pumps involved, you're talking about mechanical equipment that it breaks down a lot quicker, et cetera. 15 to 20 years, maybe 25, depending on what you're putting in for that system. And then when you get to the treatment plants themselves, again, there's lots of caveats and nuance to it, but those are even less design life, but 15 to 20 year design life for different systems. And that's really up to the permitting agency, the operators of that facility, and then any engineers behind the scenes that are helping support that to determine how often they need maintenance or how often that needs to change.
Yeah, I remember it's probably like 15 years ago now in Grand Rapids, there was a water main that blew up downtown Grand Rapids. And I remember hearing on the news, I think they said it's because it was 100 years old, and they probably should have been on this sooner, but that basically triggered, okay, now we got to replace all the water mains in all of Grand Rapids because they're all about 100 years old now. And for years, they're probably still doing it. They were digging them up and replacing them. But that is different than a sewer, right? Because a water main is under constant pressure. And so those probably wouldn't last as long, right?
Yes, correct. Those are completely different things. Some water mains can last longer than some sewers if there's different components. Either the soils has some issues or corrosivity, or there's a lot of exposure to H2S gas, which then facilitates a certain type of bacteria that eats concrete. There's a lot of nuance to that. But in general, best practices for cities to utilize is to replace a certain portion of their system every year. Just have that be kind of a rotating cost to then replace the stuff that's beyond its design life. And so your whole system is up to date.
I think I saw something on Reddit years ago where they were replacing a water main. And when they dug up the old one, what they found the water main was a series of logs with holes drilled through them. Like that was the water main, because I guess it was really old. Just interesting that apparently they used to build water mains that way.
Yeah. I lived in KC. They were putting a streetcar in downtown as part of some of the underground preparations for it. They dug up an active wood water main from like the 1850s, and it was still working, which is just mind blowing. It's impressive, really, but you should probably replace it.
Early in this conversation, we were talking about, in terms of the septic issue, like talking to a local septic installer. I think we also brought up talking to a septic designer, like a civil engineer who specializes in septic systems like yourself. But I know just the words civil engineer, like that covers a really broad spectrum of different things. If I'm trying to find a civil engineer that knows sewer and septic, what exactly am I looking for? Like, what should my Google search term be to find the right person and not just any old civil engineer who doesn't know this stuff?
Yeah. So in particular for septic, you don't necessarily need a specialist per se that is well-versed in like water, wastewater, similar to my experience. I would just look up civil engineering firms that have experience with land development or septic themselves. And some septic installers do have the certifications to do some of these more sophisticated options as well. So I would almost go to the septic installer if you're not sure if you're going to need something fancy or not. And then they'll help kind of define, because they'll know the codes and whatnot really well. If that discussion then triggers something more complex, then maybe get an engineer involved is how I would approach it. But yeah, look for septic experience and well too. If you're having septic, usually wells are part of that discussion too. And usually those are similar folks that do both.
Does it ever happen where the local jurisdiction will allow for things that shouldn't be allowed? Like, yeah, you can put a septic tank here, or this kind of soil is fine, when actually it's not fine. Like, don't do it. Are there any examples of like the local people just didn't know what they were doing and they allowed the wrong stuff to happen?
So I'm going to preface this with, you got to trust the people in office first, right? Otherwise, a lot of things kind of hit the fan and whatnot. But there have been some instances where certain people were lax in that role and it was not allowed. If the agency that is in charge of doing that says that it's okay to do it, there's rarely instances where I would say, hey, I got to question that. But you could say, hey, is this actually allowed? And you could research on the state level what those requirements are and maybe bring it up to them. But usually they give the thumbs up or the thumbs down on what can or can't be done.
So if we were to make like a one-page PDF or something about the septic sewer issue, and this is stuff we've all talked about already, but just to like summarize and make it simple, if a land investor is looking at a property, the things they should be looking at are, understanding the size of the property, maybe contacting a local septic installer just to get a feel from them, like, here's my property. Is it big enough? Do you know anything about the soil type? You know about this area? Am I on the right track or should I be scared? And then looking at things like soil types, flood maps, wetlands maps, that kind of thing. And is there anything else they should be looking at to like understand I'm okay or I could have problems?
Yeah. I mean, if you're having that conversation with the septic installer and they know the property, they've been out there, you're going to be quite a ways along the road. But yeah, it's soils, it's space. And then if there's these other conditions that would negate that opportunity, that's what you're looking for, just at a high level.
When we had talked in our pre-podcast discussion, you mentioned XP Engineering as like a consulting resource for second opinions or site audits. Can you quick explain what that is and why that might be helpful?
That's what I do. That's my firm. As a land investor and developer, I'm more than happy to give second opinions, or if you want me to take a look at something, feel free to check out the website or reach out, and we can put my email in the show notes if that's helpful, and we can go from there. But yeah, I've noticed there's sometimes working with engineers, love them, am one. We can get really focused on the mechanism of the thing versus, okay, from a land developer's perspective or investor's perspective, I just wanted a big picture, high level. Do you think it'll work and what's it going to cost? Right. And then I'm going to move on and look at my other criteria if I'm going to forego, no go. So I'm happy to kind of give that high level and have that high level discussion if it's valuable.
When you think about talking to a typical land investor just to help them understand like the situation, what they ought to be concerned about, is it mostly people who are looking to do big subdivisions or entitlement projects and they want to understand that? Or is it like literally anybody? Like I'm looking at a 1 acre parcel and I just want to know what you think, Mitch. Like, do you think I'm okay? Like, do you help with tiny little projects like that? Or like, who's the ideal client that works with you?
Yeah. So ideal client would be something of a little larger property. You're looking at multiple lots and kind of figuring out, okay, how would these layouts work, et cetera. But if it's little one-off stuff and you've got questions, I'm always interested to see what other people are up to too. And maybe I can help them along the way.
Actually, one other question. I just thought of this on the fly. So sometimes when I'm talking to a seller of a property, they mention to me, yeah, it's got a septic tank on the property. There's nothing else, but there's a septic system there. And they say that as though that's supposed to make the property more valuable in my eyes. But is it really? Could it actually be a bad thing if the septic system is actually like messed up, hasn't been looked at in 50 years, and it's a piece of junk, and if anything, I have to dig it up and replace it now? Like having an existing septic system or septic tank, what would I have to know to determine this is a good thing or this actually hurts the property's value?
You're spot on. You can have something and it doesn't work. Those are two very different realities. So what I would do, if there is something on site, that's a positive. That means you at least got a tank and a leach field in theory in place already and it's set up. You talk to local septic installers and they might be able to help you find. Some of these installers can also verify that these septic systems are functional. So you would need to get flow back through it to prove that it was working. And so I would work with them, find somebody like that to go evaluate, does it work? If you're going to purchase the property, have that be one of the contingencies on the contract to get somebody in there as part of your inspection period.
Awesome. Great tip. Again, Mitch, your website, XP Engineering, it's xpengr.com, correct?
Yep, that's right.
I'll include a link to that in the show notes for this episode. Again, REtipster.com/246. Mitch, again, awesome conversation, super helpful. I learned a lot from talking with you. Hopefully other people can get more clarity on the septic sewer situation on the properties they're looking at. And again, we're going to be having a separate podcast episode conversation as it relates to water access and installation and everything that has to do with water going to the property, right?
Yes, and I'm looking forward to it. Thank you, Seth. This has been awesome. I'm really grateful to be able to kind of merge the land and the engineering together. So I love it.
It really is a pretty useful skill set you have. It goes hand in hand with land investing in a lot of ways, whether people realize it or not. Like it just does. It's a very applicable thing to have a good understanding of. So, but Mitch, thanks again. Great to talk to you. Thanks everybody for listening, and we will talk to you again in the next episode.